Today we are going to be looking at solving story problems that would be best solved by using a system. Okay, we're going to look at multiple different pieces here, but just remembering that a system always comes with two variables and two equations. So if we look at this first story problem, it's actually just a basic translation problem, so it's knowing our key terms. 3 times a number increased by another number is 44, and the second number is 8 less than the first number. And we are being asked to find the numbers, okay? So this is asking us to find the numbers, plural, so there are two numbers we're trying to find. So we're gonna define our variables to be our first number and our second number. Now, keeping in mind that you don't have to pick X and Y, but most of my students prefer that because that's the setup we've seen. It's also the best way to check your answer in Desmos. So if we go to write an equation, we're gonna look at the first sentence. When we are writing equations with basic translations, right, we're going in the order we read. So we see 3 times a number. So the first number that I picked is X, so I'm gonna say 3X. Increased by means addition. Another number. Okay, so now I'm picking another number. I already used X, so the next number I picked was Y. Is means equals 44. Okay, when we end a sentence, we are ending an equation. So because we see that period there and we're starting a new sentence, we are going to start writing a new equation. The second number, now this doesn't mean any of the numbers from our first sentence. It means what was the second variable that we picked? And the second variable that we picked was Y. Again, is equals 8 less than. Less than is the most common missed basic translation. My students know that it's subtraction, but what they don't do is flip this order. Less than tells us to flip the order, right? If I say 2 less than 10, we're really taking 10 minus 2. So I need 8 less than the first number. The first number was X minus 8. Now, technically speaking, we can solve this by any method that we want to solve this with, but this problem is set up for substitution, right? We have this X equals or Y equals, okay, which says anywhere that I see Y, I can replace it with X minus 8. So this Y is gonna get replaced with X minus 8, and I'll have a new equation that says 3X plus X minus 8 equals 44, and then that's just something I need to solve just with our basic solving equation skills. And that gives me 13. Again, we are not done with 13, right? We need to find both numbers. So we need to take this 13 and we need to plug it in up here where we underline. So I'll say Y equals 13 minus 8. So I'll say Y equals 5. And so my two numbers will be 13 and 5. Okay, our next story problem that we are going to look at isn't a basic translation, but a natural story problem. So adult tickets to see a play cost $22. Tickets for the children cost $15. And tickets for a group of 11 people cost a total of $228. We're gonna write and solve a system of equations to find how many children and how many adults were in the group. So the question is telling us our variables, right? How many children and how many adults. It doesn't matter which you label, X and Y. You could flip-flop those as well. It just happens to be the order I saw them, so that's the order I wrote them down in. Okay, so we know it is a total of $228. So remember, our total rule says blank plus blank equals a total of $228. Okay, so it's gonna be the adult tickets plus the children tickets that are gonna total $228. But each adult ticket and each child ticket doesn't cost the same amount, right? An adult ticket costs $22 and a child ticket costs $15. So 15 is representing money, 22 is representing money, 228 is representing money. Okay, the other piece that I know in this story problem is that a total of 11 people went. So again, it is a total. The adults plus the children have to be a total of $11. Now, when people walk into a room, whether it is an adult or whether it is a child, a person still counts as one person. So each adult and each child cost is one person. So how much each person is worth, how much each person is worth, total of all the people together. So this is the system we now need to solve, right? When we are solving this, it is stacked like elimination, but we don't see a matching coefficient. So remember, this is where we said we want to multiply one of the equations. So I could multiply this bottom equation by negative 15, right? Because 1 times 15 is 15, and I want them to be the opposite signs. So if you forget how to do that multiplication, you might want to go back and watch some of the past videos on how we solve those systems by elimination. So my top equation stays the same. And my bottom equation becomes a negative 15x. Right, I'm going to distribute here a negative 15y. And then a negative 15 times 11 will give me a negative 165. Okay, so now I have matching coefficients. So now I can add straight down, right? 15 plus negative 15 cancels out, which is what I want. 22. And negative 15 gives me a 7y. So I'm just using my calculator because I don't know. So 63. Right, this gives me something I can solve. So I'll get y equals 9. But again, I'm not done with y equals 9. I need to take that value and I need to plug it back into one of the equations for y. So 1x plus 9 equals 11. Okay, now I need to interpret what this actually means. This isn't just an ordered pair of 2, 9 because I'm solving a story problem. This is telling me x is 2, x is children. So this is saying there were 2 children, 9 is adults, and there were 9 adults that went. Number 3, shopping at Savers Mart, Lisa buys her children 4 shirts and 3 pairs of pants for $108.50. She returns the next day and buys 3 shirts and 2 pairs of pants for $77. What is the price of each shirt and each pair of pants? So again, what it's asking us to look for is our variables, right? So x is going to be the cost of a shirt, and y will be the cost of a pair of pants. Okay, so when we read, she purchased 4 shirts and 3 pairs of pants for a total of $108.50, right? So 4 shirts, 4x, plus 3 pairs of pants, 3y, equals $108.50. Right, my second situation is 3 shirts and 2 pairs of pants for a total of $77. So 3 shirts, right, shirts is x, and 2 pairs of pants, pants is y, for a total of $77. Okay, these are stacked like elimination. So I'm going to want to solve these with elimination. None of those coefficients match on those variables, so I'm going to need to do some multiplication. So again, you can choose where you want to multiply. There isn't a right or a wrong, right? But if you don't know anything else to do, the statement we came down to is we could pull this 3 up on top and this 4 down on bottom. Right? These are both positive. They're the same sign, and we do not want them to be the same sign, so we need to put a negative on one of them. So our top row, I'm going to distribute that 3 all the way through. 12x plus 9y. I'm going to use my calculator here. 108.50 times 3 gives me 325.50. Okay, and then my bottom equation, a negative 12x minus an 8y equals negative 308. Okay, now I have those matching coefficients, so now I can add straight down. 12 plus negative 12 cancels out. A 9 plus a negative 8 gives me a 1y, or just a y. When I add that, that's going to give me a 1750. Okay, but I'm not done because I need to plug that back in. Right? I need to plug that back in somewhere, and I need to make sure I am plugging it in for y. So if I say 3x plus 2 times 1750 equals 77, Again, now I'm just solving an equation. Next will be 14, right? So this says that it is $14 X with shirts for a shirt and $17.50 for a pair of pants. Now, I would strongly recommend that you pause the video and you try and do this next story problem on your own, just to make sure that you can write those two equations and get a system wrote, but then play and make sure that you did it correctly. So a resort offers two activity packages. One of the packages costs $192 and includes 3 hours of horseback riding and 2 hours of parasailing. The second package costs $507 and includes 5 hours of horseback riding and 7 hours of parasailing. What is the cost for 1 hour of each activity? Now the key here is making sure we define our variables based off of the question, not anything that we're reading. There's two things up. So it's a little bit tempting to pick package 1 and package 2, but package 1 and package 2 are my two equations, not my two variables, right? This is wanting what is the cost for 1 hour of each activity. And my two activities, so this is going to be my cost per hour of horseback riding. Oops. And my Y is going to be my cost per hour of parasailing. Okay, so in situation 1, I have a total of $192. Right? That includes 3 hours of horseback, so 3X, and 2 hours of parasailing, 2Y. Okay, the second package costs $507. So that's a total. It includes 5 hours of horseback, so 5X, because X is horseback, and 7 hours of parasailing. So this is now what I need to solve. So again, I'm going to need to multiply to make these match. There are multiple ways that you could multiply. Your final answer in the end just needs to be the same. Give me negative 960. $1,521. Okay, so now I'm going to add these two equations. So my x's will cancel out because there's matching coefficients but opposite signs. 11y equals 561. Okay, that'll be y equals 51. Again, I'm not done with that. I need to plug that back into one of the equations, and I need to plug it in for y. So 3x plus 2 times 51 equals 192. So it'll be x equals 30. So that says it's going to be $30 an hour for horseback riding and $51 an hour for parasailing.